Hello, good day everyone. Welcome to another live section of solving Cambridge past papers. Today we shall be looking at Mechanics paper 4, variance 3, May-June 2023, 9709, paper 4, variance 3. Now the first question, now two particles, P and Q, two particles, P and Q, of masses 0.1 kg and 0.4 kg respectively are free to move on a horizontal plane. They're on the horizontal plane. One is P, one is Q. Particle P is projected with a speed of 4 meters per second toward Q, which is stationary. Q is 0.4 kg. It's stationary, it's not moving. So the initial velocity of P is 0. P, which is 0.1 kg, is projected toward Q. The initial velocity of P is 4 meters per second. This is P, this is Q. After P collide with Q, the speed of P and Q are equal. After collision, the final velocity of P, I don't know it, is x. The final velocity of Q is also x. They are equal. That's V1 and what? V2. Find the two possible values of the speed of P. Now, the two possible values are like this. Remember that Q is stationary. Two things are possible. It's either after P collide with Q, they move in this direction. Both of them move in the direction of the heavier mass. It's either they move in this direction or after collision they bounce back in opposite direction. Remember that Q is stationary. So when P hits Q will move a bit to the right, while P will bounce back. You know why it's bouncing back? Because Q is heavier than P. So it bounces back and Q move a bit to the right. So these are the two possibilities. So the question asks us to find. Now this is the first possibility. I call it equation 1. This is the second possibility. Now using the principle of conservation of linear momentum. Let's do momentum before collision. Remember that before collision, mass is 0.1 for P, the velocity is 4, plus Q is stationary, that's 0.4 times 0. So before collision will always be 0.4 Newton seconds. That's momentum before collision. Hold on. Let me do it in Newton second. Kilogram meter per second. Kilogram meter per second. Now, momentum after collision. Let me use the first case. The first case is when they move in the same direction toward the x-axis. That's positive. That will be the mass of P is still 0.1. I don't know the velocity of P, x, plus the mass of Q is 0.4. I don't know the velocity of Q, that's still x. You know I said x, but the question said that after collisions, the velocity are equal. The reason why I added them together is because they are going toward the x direction. An x direction Cartesian like this, here is positive. This positive x, they are going toward that direction. At the end of the day, we have 0.1x plus 0.4x. That gives us 0.5x. So using the principle of momentum before collision, 0.4. For the first case, momentum after collision is 0.5x. So the value of x is 0.4 over 0.5. So in that case, we're going to have probably 4 over 0.4 divided by 0.5. That's 0.8. So the speed in the first case is 0.8 meter per second. That's that one. So the next one is for the second case. Now, for the second case, momentum after collision is, for this is the second case. This is the second case. After collision, see what happened. One moved toward the positive x-axis, the other moved toward the negative x-axis. So P is moving toward the negative, and the mass of P is 0.1. So the velocity is minus x plus Q go toward the positive x-axis. That's 0.4 multiplied by positive x. At the end of the day, momentum after collision here is 0.1x plus 0.4x, which will give us 0.3x. So using the principle of momentum, momentum before collision is fixed, 0.4. After collision for the second case is 0.3x. So x is 0.4 over 0.3, which gives us 4 over 3 meter per second. So these are the two possibilities of velocity, 0.8 and 4 over 3 meter per second. 4 over 3 can also be 1.33 meter per second. These are the two possibilities. Remember that my x is what I represent as velocity. So let me put it there. Okay, I've already said that earlier. So second question. A car of mass 1,500 kg, 1,500 kg. Let me use blue color for the car, 1,500 kg. No need of swapping color, I'll just label it. This is the car. The car and the trailer, a car of mass 500 kg is towing the trailer. The only way you can tow a trailer is by using a rope. So we don't know the mass of the trailer. M. Remember that tension is always, the force in the wire is always tension, and it's always stretching out like this. Doesn't stretching, it's always stretching out. So Now, there's a resistance force of F Newton on the car. So there's a resistance force on the car. This is the car. There's a resistance force on the car. The resistance force on the car and the resistance force of 200 Newton on the trailer. The resistance force on the car is F. On the trailer, that's what is opposing it, is 200 Newton. The driving force on the car engine is 3,200 Newton. What's the formula for force? What's the formula for force? The driving force. Okay, no need. What is driving it? What is driving the car engine? Say what is driving the car engine is 3,200 Newton. The acceleration of the car is accelerating, is 1.25 meter per second squared. The tension in the tow bar, the tension between the car and the trailer, this is the trailer, the tension there is 300 Newton. It's 300 Newton. So remember I said tension is always stretching out. So find the value of M and F. First, F is resistance force on the car. Let me consider the car first. Considering the car, let me check my space. Considering the car alone, look at the car. The mass of the car is 1,500 kg. I'm considering the driving force on the car is 3,200. There are two forces in opposite direction to the driving force. The tension force, 300 Newton, and the resistive force, which we don't know. Now, to find the resultant force in such case, resultant force will be 3,200 minus sum of opposite forces, 300 plus F, the opposing it. According to Newton's second law of motion, resultant force is mass times acceleration, and the mass in question is the mass of the car, 1,500. The acceleration is 1.25, equal to 3,200 minus 300 plus F. Now 1,500 times 1.25, we have 1875. 1875. So plus this one comes to this side. 300 plus F comes to the other side, equal to 3,200. So 1875 plus 300, 2175. So F will be 3,200 minus 2175. So our F is, so the F is 1025 Newton. That's the F. Now, we also asked to find the value of what? M. We are asked to find the value of M. Now, when I'm looking for frictional force F or resistive force against the car, I do the car free body diagram. Let's draw the free body diagram for the trailer. This is the trailer. This is the trailer. The trailer has a mass of M. I'm considering the trailer alone in this case. So resistive force is resistance force is 200 Newton. In this case, the tension for the trailer will be opposite direction to the tension of the car, because it's the same tension, it's the same rope binding car and trailer, so they'll be equal and opposite. So in this case, it will be in other direction like this. So I remember that the value of tension is 300, but at the same time is accelerating in the same direction. Is accelerating like that. So the same acceleration, they have the same acceleration because they are binded together. So in that case, resultant force for trailer will be 300 minus 200. So MA, according to Newton's second law of motion, resultant force is mass and acceleration. The mass is question is m, we don't know it. Acceleration is 1.25. 300 minus 200, 100. So mass is 100 over 1.25. So the mass is 80 kg. The other way, okay, I think there's this space. Alternatively, we can also do it like this. Now, alternatively, let's consider the system. Let's consider the system. What I mean by the system is both the car and the trailer. Let's consider it together. I drew the trailer. This is the trailer. I'm considering the system anyway. The resistance force here is 200 Newton. This is the car. The mass of the car is 1,500 kg. Trailer is M. Driving force is 3,200 Newton. Since I'm considering the trailer, we are considering the trailer. So from here, considering the trailer and the car together. So now this is resistance force of the trailer. Resistance force for the car is 1025, the one we got before. Both the system, the trailer and the car, they are accelerating with 1.25. When you are considering the system, you neglect the tension, the rope, because at the end of the day, they are going the same direction. So you neglect the force on the rope. You only consider the basic force, the resistance force of the trailer, the resistance force of the car, the driving force. Just consider the external forces. The rope is inside that bind them together. So in this case, resultant force will be the one pushing it forward, 3,200, minus the sum of resistive forces, resistance force of the car and resistance force of the trailer. According to Newton's law, resultant force is ma. Since you are considering the system, the mass is sum of the two masses. Acceleration is 1.25. 3,200 minus this, let's see it, 3,200 minus 1,225. That's 1,975. So 1,500 plus m will be 1,975 over 1.25. So 1,975 divided by 1.25, we have 1,580. We have 1,580. So 1,500 plus m equal 1580. So m is 1580 minus 1500. So the mass still gives us 80 kg. That's it for that. Now number three question. A smooth ring R of mass 0.2 kilogram is threaded on a light string ARB. Okay. The end of the strings are attached to the fixed point A and B. You can see. So it's like this. It's like this. The end of the string is attached to, so this is tension, this is tension, this is, the string is ARB, the wire is ARB, the string. So the string is held at point A and also at point B in this direction I just labeled, with a vertical, with A vertically above B. If here is 60, here is 90, of course. Here will be 30 degree, here will be 30. The string is taut at angle AB or 90 degree, as you can see. The angle between the part AR, the angle between the part AR of the string is vertically is 60 degree. The angle between parts AR of the string, you can see, is 60 degree. The ring is held in equilibrium by a force. Another force of X Newton balance the other forces to the right in a direction perpendicular to AR. Okay, that's calculate the tension in the string and the value of X. Okay, the tension in the string and the value of X. Okay, from here, this is the weight of this ring. The weight of the ring is 0.2 g, the exact weight downward. And this is 90. This face is 90. X Newton is held at a particular angle. So we need to resolve X vertically. This X, we resolve it vertically and horizontally. Vertically and horizontally. Because the reason I'm resolving it vertically and horizontally is because it's placed at a particular angle. When a force is placed at a particular angle in mechanics, you have to resolve the force. This is 30, this is 30, this is 90, 30, 90, this is 30, this is 90. Automatically here will be 60. Angle on a straight line, that the sum is 180, so that place will be 60. So I have two triangles now. I have tension T. I have tension T like this. Here is 60. I need to resolve T. To resolve T, this is 30. Why this is 90? This T, I need to resolve it horizontally and vertically. Opposite, this is vertical, this is horizontal. So the vertical is Y, sine 30, opposite over hypotenuse. So Y is T sine 30. So the X for that T, adjacent over hypotenuse, T cos 30. Vertical, this horizontal. The same thing happened to X. The same thing happened to X. This is X. Here is 60. I need to resolve X vertically and horizontally. sine 60 vertically and horizontally. To do that for x, this is vertical. Opposite coming. Let me check it. Okay. Now let me use the same thing. So it's confusing. Let me call this spaces vertical for x, horizontal for x. Sorry, FH, horizontal force. So sine 60 equal to vertical force over hypotenuse. So the vertical force for x when it cross multiply is x sine 60, and horizontal force for x adjacent over hypotenuse. So horizontal force for x is x cos 60. Okay, I've resolved them. So remember that there's a point that the question said that the ring is in equilibrium. The ring is in equilibrium. So when forces are in equilibrium, sum of vertical forces must be equal to 0. Sum of horizontal forces must be equal to 0. Now, what are the vertical forces? Now, one of the vertical forces is this, T sine 30. One of the vertical forces is this, X sine 60. One of the vertical force is 0.2 g, the weight, but the weight is in opposite direction to this one. You know, these ones are here and here. The weight is opposite, so that will be minus 0.2 g. This is the sum of the vertical force equal to 0. So what do you have here? T sine 30. Let me check my space. Okay, T sine 30 plus X sine 60. 0.2 g is minus 2 equal to 0. This is equation 1. Equation 1 is obtained by using sum of vertical forces equal to 0. Now, using sum of horizontal forces equal to 0 too, we're going to have for this is the horizontal force for this one, T cos 30. That's the horizontal force for T, for tension. Horizontal force for the force of X is X cos 60. Okay, we need to be very careful in this case. We have 3 horizontal forces too. Don't forget that, you know, we have two rope. We have two rope holding the ring to the other side. So this T, the second rope, only has horizontal force to the right, to the left. So we have 2 horizontal force in this to the left. 2 horizontal force. The first T and the second T. The first T horizontal force is they are to the left. Since they are to the left, is negative T. The other horizontal force to the left is minus T cos 30. So, and the last horizontal force to the right, that's the horizontal force of X. So the right, that's plus X cos 60 equal to 0. So at the end of the day, I have X cos 60 equal T plus t cos 30. Let me simplify this. I can get the value of x in this case. X cos 60 will be t plus cos 30 is cos 30 is 0.8660 t. When you add them together, we have 1.8660 t. So x cos 60 is 0.5. Cos 60 is 0.5. This one gives us 1.8660 t. So the value of x will be 1.8660 t divided by 0.5. So 1.8660 divided by 0.5. So x will be 3.732 t. That's the value of x. So substitute the value of x in equation 1, the first resolution. Equation 1 is t sin 30 plus x. X is 3.732 t sin 60 minus 0.2g, that's 2, equal to 0. Sin 30 is 0.5 multiplied by t, 0.5 t. Sin 60 is 0.8660 multiplied by 3.732. We have 3.232. There's t there, minus 2 equal to 0. Plus 0.5 t. We have 3.732 t equal to 2. In this case, t is 2 over 3.732. So 2 divide 3.732. So t is 0.536 Newton. That's the value of t. We also have to find the value of s. Hence, remember that we obtained an expression for x to be 3.732 t. So x will be 3.732 t and t is 0.536 multiplied by 3.732. So our x will be 2 Newton. So the question asks us to find the value of x and t. So t is 0.536 Newton, x is 2 Newton. I believe it's clear. Number 4. A lorry of mass 1,500 kg. A lorry of mass 1,500 kg moved on a straight line on a straight horizontal road, direction of A to B. So which means it might have passed A before. Let me draw the straight line first. From A to B. This is the lorry. It's moving on a straight line. The mass of the lorry is 15,000 kg. You need to be very careful of zeros. Can be dangerous once you mix them. So the mass of the lorry is 15,000 kg. Now, when the lorry passes A, with a velocity of 20 meters per second. The lorry passes B with a velocity of 25 meters per second, according to the question. Now, the power to the lorry is constant, and there's resistant motion resisting the lorry or slowing the lorry down to be 6,000 Newton. Now, the power is constant. The mentioned power is FV. So driving force will be power over velocity. So the driving force is power over velocity. Again, the question said the acceleration at B is 0.5 times the acceleration at A. I don't know the acceleration at A. Let me call it P. Let me call it Y. Sorry. So acceleration at B is 0.5 that of A. That's 0.5 Y. So we have two accelerations. The reason because the velocity are different. Now the question is show that the lorry's engine power is 200 kilowatt, and then find the acceleration of the lorry at A. That's the one at 20 meters per second. Now let's go back to the lorry. There are two forces acting on the lorry: the driving force driving the engine and the resistive force. So using Newton's second law of motion, now resultant force acting on the lorry is resultant force. Let me use this. So acting on the lorry, resultant force is the driving force minus the resistive force, 6,000. Remember that at A, everything is different at A. Resultant force is mass times acceleration. The mass of the lorry is 15,000. At A, the acceleration is Y. Power over at A, the velocity is 20 minus 6,000. At the end of the day, when you simplify, 15,000 multiplied by 20, we have 300,000. So 15,000 times 20, we have 300,000 Y. This 300,000 Y equal to 20 times 6,000. That's 120,000 minus 120,000. So here, power will be 300,000 Y plus 120,000. I'll call it equation 1. At B, velocity changes, acceleration also changes. The mass is still the same, 15,000. Acceleration is 0.5 Y equal to power over velocity. Velocity at B is 25. The resistive force is still constant. So therefore, when you simplify these two, we have 18,750 Y equal to P minus 150,000. At the end of the day, P in this case will be 18,750 Y plus 150,000. Equation 2. Equate equation 1 and equation 2. Equation 1 is 300,000 Y plus 120,000. Equation 2 is 18,750 Y plus 150,000. Collect the lifetime. 300,000 minus 150,000. 300,000. Let me check it. Oh, 300,000 y. 300,000 y minus 18,750 y. I think we have. Let me check it. Minus 18,750. 112,500. This one gives us 112,500 y. 150,000 minus 120,000. That gives us 30,000. So y is 30,000 divided by 112,500. So 30,000 divided by 112,500. We have 4/15. Remember that y is acceleration. So 4/15 meter per second square. So this is acceleration at 20 meter per second. We also have to find the power. To find power, use either of the equation. Let me use equation 1. Using equation 1, power is 300,000. Y is 4/15 plus 120,000. So 4/15 times 300,000. 300,000 times 4 divided by 15. That's 80,000. So 80,000 plus 120,000. It gives us 200,000 watts or 200 kilowatts. That's the power. The next question. The lorry begins to ascend a straight hill 1 degree to a horizontal. Now, the lorry has changed direction. It's no longer a straight line. It's inclining. It's going on inclined side. The lorry is now inclined at an angle of 1 degree. Here is 1 degree. This is the lorry. It's now inclined. The question said the power of the lorry and the resistance do not change. So driving force is 200 kilowatts over velocity. The resistance do not change. The resistance is 6,000 Newton. Don't forget that power is FB. Force is always power over velocity. Okay, let me draw it clearly. So let me draw it so we will know to be clear. So in this case, let me do it here. $1 degree. The lorry. Driving force, power. They said the power is still the same thing, 200 kilowatt. Power over velocity. The resistive force does not change, 6,000 Newton. Don't forget to resolve incline. When you are resolving, here is mg. This is mg cos theta. This place is mg sin theta, which is parallel to this place. It's parallel to this place. They are parallel. So here too, down the inclined plane will be mg sin theta. They are parallel. The question mentions something that find the steady speed. Steady means acceleration is zero, constant velocity. Acceleration is zero. So what is the force acting on the lorry in this case? The force, resultant force will be driving force 200 kilowatt over velocity minus velocity force. Velocity force is 6,000 plus mg sine theta. They are the ones velocity in the driving force. And according to Newton's law, resultant force is mass times acceleration. In this case, the acceleration is zero because it's steady. 200 kilowatt over velocity minus 6,000. Mg sine theta will be 1,000. That's 15,000. 15,000 times 10 times sine 1 degree. So it's going to give us 8617.86. So, no. I've already added them together. Let me do it properly. Mg, remember that mass is 15,000. G is 10. Multiplied by sine theta, that's sine 1. Okay, that gives us 2617.86. So this go to the other side. When you add them together, 6,000 plus that, it will give us 8617.86 equal to 200 kilowatt over velocity. Cross multiply and make velocity the subject of the formula. That will be 200 kilowatt over 8617.86. When you divide this, we have 23.2 meter per second. That's the constant velocity of the hill. 23.2 meter per second. So the velocity changes when it climbs the hill. Number 5. A particle starts from rest. Since the particle is starting from rest, no distance at rest, the time at rest is 0. Initial velocity at rest is 0. Take note of that point. Move in a straight line. The acceleration of the particle at time t after leaving O is a. After leaving point O, that's at rest, the acceleration is given as kt raised to power r. This acceleration between 0 and 9. Between. The velocity, including 0 and 9 anyway, the velocity of the particle when the time is 9, velocity is 1.8. Show that k is 0.1. Since a is kt raised to power r, what's the definition of velocity? Velocity is acceleration is dv over dt equal to kt raised to power r. Cross multiply, the v is kt raised to power r dt. Then integrate both sides. When integrate the v, we have v. When integrate kt raised to power r, we have kt r plus 1. You know, integration, you have to add 1 to the power. Bring the total power down plus arbitrary constant. So when you simplify kt raised to power 3 over 2 divided by 3 over 2, it gives us 2 over 3 kt raised to power 3 over 2 plus arbitrary constant. the first condition. Remember that at rest, velocity is 0 at rest, time is 0 at rest. Velocity is 0 at rest, time is also 0 at rest. So c will be 0. So the equation for velocity will be 2 over 3 kt 3 over 2 plus 0. Remember that when the velocity is 1.8, the time is 9. So 1.8 equal to 9 raised to the power 3 over 2. 3 square will give us 27. 27 times 2, 54. 54 divided by 3, that's 18. So this one will give us 18k. So k is 1.8 divided by 18. That gives us 0.1. That is what they asked us to show. Show that k is 0.1. So the equation will now, generally the equation will now become a equal to 0.1 kt raised to the power half, because k is now 0.1. B part. For t greater than 9, for t greater than 9, the velocity of v of the particle is given as this. Remember that between 0 and 9, we have a velocity. Now, greater than 9, they've given us a velocity greater than 9 now. Show that the distance traveled in the first 9 seconds, the distance traveled s in the first 9 seconds is the distance traveled in the first 9 seconds is 1/10 the distance traveled between 18 and 9. Between 18 and 9. Now, we need to get the distance in the first 9 seconds. When you check this acceleration given is between 0 and 9. That's the acceleration in the first 9 seconds, which is this. Let's get the velocity in the first 9 seconds. Then you get the distance traveled in the first 9 seconds. Now, so what's the velocity? The velocity now, okay, already we know the acceleration for the first 9 seconds, which is this one. This is the acceleration for the first 9 seconds. So the velocity for the first 9 seconds, the velocity for the first 9 seconds will be, this acceleration for the first 9 seconds. Oh, I think we did that before when we integrated acceleration. So the velocity for the first 9 seconds will be 2 over 3 kt raised to the power 3 over 2. And you check our first analysis here. And you check what I did here. When you check what I did here. So I finally got the velocity for the first 9 seconds, where c is 0. So you agree with me that this is the velocity for the first 9 seconds is 2 over 3 kt raised to the power 3 over 2. I'm looking for distance. Remember that k is 0.1. I'm still coming there. Since velocity, now let me do it like this. I'm trying to look at the space. Okay. For the first 9 seconds, that's between 0 and 9, velocity is 2 over 3 kt raised to the power 3 over 2. And velocity is ds dt, which is 2 over 3 kt raised to the power 3 over 2. So ds is 2 over 3 kt 3 over 2 dt. So let's get distance. So to get distance, integrate both sides. So integrate ds, we have s. So we are going to integrate this one too. I brought out the constant. So 2 over 3 k. When you integrate that, it give you t raised to the power 5 over 2 over 5 over 2. So s is 2 over 3 times 2 over 5 kt raised to the power 5 over 2. So s will be 4 over 15, and k is 0.1, that's 1 over 10, t raised to the power 5 over 2. So the distance in the first 9 seconds is 4 over 150, t raised to the power 5 over 2. That's distance the first 9 seconds. Now, okay, let me just complete it and put when t is 9. When t is 9, the distance is 4 over 150 multiplied by 9 raised to the power 5 over 2. So the distance is 6.48 when t is 9 meter. Now, don't forget the key. This is the key. This is what I'm going to show. Now I have the distance for 9 seconds. Let me get the distance for the between 9 and 18. Let's get the distance. Already between 9 and 18, that's over 9 seconds. Or this is the velocity. So between 9 and 18, this is the velocity. The velocity is 0.2 t minus 9 square plus 1.8. Remember that v is ds over the t, equal to 0.2 t minus 9 square plus 1.8. So at the end of the day, integrate both sides. Integral of ds equal to integral of 0.2 t minus 9 square plus 1.8 dt. So when you integrate ds is s. So when you integrate this, we have 0.2 t minus 9 over 3 all over 3. When you integrate 1.8, we have 1.8 t. I'm very sure you're okay with your integration. So here we have 0.2 over 3 t minus 9 raised to the power 3 plus 1.8 t. Don't forget it's between 18 and 9. So let's do the right thing. When x is 18, 0.2 over 3, 18 minus 9 cubed plus 1.8 times 18 minus when t is 9, 0.2 over 3, 9 minus 9 cubed plus 1.8 times 9. So from here we have s will be 18 minus 9 is 9. 9 cubed will give us, let me check, 9 cubed, 9 times 9, 729. 729 times 0.2 divided by 3, this 48.6. 48.6, 1.8 times 18, 32.4, minus this one will give us 0. So 1.8 times 9, 16.2. 16.2. So 48.6 plus 32.4 minus 16.2. We have 64.8. So distance between 9 and 18 give us 64.8 meters. When you check this is distance between 9 seconds. Distance between the first 9 seconds is 6.48. You check it, is 1/10 of distance between 18 and 18 to 9. That's it. So that's what they asked us to verify. C. Find the greatest acceleration of the particle during the first 10 seconds of the motion. First 10 seconds falls in between 9 and 18. And the velocity in between 9 and 18 is v equal to 0.2 t minus 9 squared plus 1.8 t. So first 10 seconds fall into that. We are looking for acceleration. First 10 seconds. Acceleration is dv dt, which means we are going to differentiate that velocity. That will be 2 times 0.2, 2 minus 1, plus 1.8. So it gives us 0.4 t minus 9 raised to the power 1 plus 1.8. So we differentiated that. Is it 1.8 t or 1.8? Oh, 1.8. So it's 1.8. So when you differentiate 1.8, that's 0. When you differentiate a constant number, that's 0. So acceleration will be 0.4. The first 10 seconds, t is 10. So at the end of the day, acceleration is 0.4 meter per second square. That's what the asked us to look for. Number 6. An elevator is pulled vertically upward by a cable. The elevator accelerates at 0.4 meter per second square for 5 seconds. Okay, this is something like that. Okay, maybe I think it's going to be a graph. This is from rest. This is 0. Accelerate for 5 seconds. For 5 seconds. The acceleration is 0.4 meter per second square. But we don't know the velocity at which it attained that, because this is for velocity and this is for time. Then travel at constant speed. At that constant speed, at that same speed, travel for further 25 seconds to make this place 30. The elevator then decelerate at 0.2. We don't know the time it comes to rest. but deceleration is 0.2 meter per second squared. Find the greatest speed of the elevator and draw the velocity time graph of the motion. Okay, the speed is, what's the acceleration? Velocity over time. You know, and acceleration is 0.4 with velocity over time. So what's velocity? So velocity is 0.4 times 5. 0.4 times 5, that's 2 meters per second. So this side is 2 meters per second. Let's complete the diagram. We need to get this t. The body decelerated at 0.2 at this particular time. Acceleration is also velocity over time. At this last angle, the deceleration is 0.2, velocity is 2, the time is t minus 30. Deceleration occurs between this time, between this region, t minus 30. So cross multiply, we have 2 equal to 0.2t minus 0.2 times 30, 2 over 10, I think 6. So 0.2t equal to 8. T is 0.8 divided by 0.2. So our t should be 8 divided by 0.2, that's 40. 8 divided by 0.2, 40. So this time here is 40. So this is the diagram. Next one, find the distance traveled by the elevator, the total distance. You know, the diagram is a trapezium. So total distance travel is area under the graph. Total distance travel for a velocity time graph is area under the graph. So distance equal to area under the graph. Area under the graph is area of the trapezium. Half bracket sum of the parallel side multiplied by the distance that separates the parallel side. So A is the small side from here to here, which is 25. B is the longer side from here to here, the long line, which is 40. The height, which is the speed, so 2 cancel 2. So the distance traveled is 65 meters. That's it. The third one, the mass of the elevator is 1,200 kg. Mass of the elevator. And there is a crate of mass m kg resting on the floor of the elevator. Oh, maybe something like this. Inside the elevator, the mass of the elevator itself is 1,200. Inside it, there's someone inside it, a crate of mass m. The weight of the elevator is like this. Weight is mg. The mass of this stuff is 1,200 plus m multiplied by g. This is the cable attached to the elevator. Tension is always stretching out. You know that. So, given that the tension of the cable is decelerating, given that the tension in the cable when decelerating is 2250, so tension is 122.50 Newton. Find the value of it when decelerating. Of course, when decelerating is when the elevator, when decelerating, acceleration will be negative. First, before we do that, tension is stretching up, weight is going down. So resultant force in this case, up is positive, down is negative. Weight is negative, tension is positive. Resultant force is plus tension minus weight. Newton's law, force is ma. In this case, the acceleration is negative because it's decelerating. Tension minus weight. So minus ma plus weight equal to tension. Now, mass in this case, they consider the mass of the elevator and the mass of the crate inside. And what is deceleration is 0.2. And you check, see our diagram, our previous diagram. Deceleration wing 0.2 plus weight. The weight is mg. M is 1200 plus m multiplied by g equal to tension. Ma. Sorry. Here is Ma. The mass is 1200. 1200 plus m. This is Ma. This is weight equal to tension. Tension is 12250. So from here, what do we have? Okay, this is minus 1200 plus m times 0.2 plus this is the mass 1200, 0.2 plus weight. Open a bracket. This one will give us 1200 g, and g is 10. Add almost 0 plus mg, that's 10n, equal to 2250. Open the bracket by 0.2, so 1200 times 0.2, 240. So here I have minus 240 minus 0.2 m. I'm just opening the bracket, plus 1200, 12,000 plus 10n equal 12250. So 12,000 minus 240, what do you have? 12,000 minus 240, 11,760. Minus 0.2 plus 10n, that's 10 minus 0.2, that's 9.8. 9.8 m equal 122250. 12250 minus 11,760, 490. 9.8 n equal to 490. So n is 490 divided by 9.8. So m is 50 kg. That's the mass of the crate, 50 kg. D, the last question. Find the greatest magnitude of force exerted on the crate by the floor of the elevator and its state direction. Find the greatest magnitude of force. Greatest magnitude of force will occur when the body is accelerating. This side, this wing, when it's accelerating. And when it's accelerating, it's still the same. At that point, acceleration will be positive, not negative. When it's accelerating, it's still going to be tension minus weight, but in this case, acceleration is positive. That's just the logic. Don't cram any direction, just your sign. So tension, in this case, it says find the greatest force exerted on the crate. That this kind of amount is, instead of tension, I'm going to use reaction, but it's still the same anyway. So what's our mass? Our mass says find the greatest magnitude of force exerted on the crate. So mass of the crate is what we are dealing with. 50 times 10. 50. When it's accelerating, that the value is 0.4. What do you have here? 50 times 0.4, 20, plus 50 times 10, 500. So at that point, we have 520 Newton. And the direction is upward, it's accelerating. So which means when it's decelerating, it's downward. The last question, number 7. The diagram shows the vertical cross section XYZ on a rough slide. Okay. The section YZ is straight line. The length is 2 meters, as you can see. Inclined at an angle alpha to the horizontal, where sine alpha is 0.28. The section YZ is tangential to the curve XY at Y. It's tangential to the curve at Y, okay? And X is 1.8 above the level Y. A child of mass 25 kg slide down the slide, starting from rest at X. So velocity at X is 0. The work done by the child against resistant force. Why do we have resistant force? Because it's rough, it's a rough surface. It's moving the work done against resistant force. That's an external force. The same thing as work done against resistant force, 50 joules. From X to Y. Find the speed at Y. Now since there's a resistive force between X and Y, there's a resistive force. So what will happen is this. Kinetic energy at X plus potential energy at X will be equal to kinetic energy at Y plus potential energy at Y plus work done against the external force. This is the principle of conservation of energy. Between X and Y. I added work done against the external force because of the rough surface. If there is no rough surface there, total energy at X should be the same thing as total energy at Y without this external force. Since there's a rough surface, you have to add external force to the final part. That's the logic. So what's kinetic energy at X? 0. Because the body is at rest at X. At X, what's the potential energy? mgh. M mass is 25. Gh. H is 1.8. That's the height to X. Kinetic energy at Y. Half mv square. I don't know the speed at Y. Potential energy at Y, 0. For the height, becomes 0 here. What's the work done against external force? 50. What's the work done against resistance? That's 50. So from here we have 0. 25 G times 1.8. What do we have? 25 G times 1.8. That's 450. I guess. That's 450. 25 G times 1.8. That's 450. Equal 25 over 2 V squared plus 50. At the end of the day, this comes here. We come from the 25 V squared over 2. So 800 equal to 25 V squared. So 800 divided by 25, 32. V squared is equal to 32. Square root of 32, 4 root 2. That's 4 root 2 meter per second, or 5.6568, 5.66 meter per second. That's the speed at y. That's the speed at y. Now, the next question. It's given that the child comes to rest at z. At z, the child comes to rest. Use the energy method to find coefficient of friction between the child and yz, giving your answer the fraction in simplest form. The yz, remember that the child comes to rest at yz. At yz, there is no velocity then. It comes to rest. There is no height. So at z, kinetic energy will be 0, potential energy will be 0. There is no height there and there is no velocity. But at y, we have velocity at y. So at y, kinetic energy at y will be half m v square, and v square is 32. So kinetic energy at y will be 16 times 25, 400. 400 joule, 400. Potential energy at y. I don't know the height at y, but sine alpha is equal to opposite over hypotenuse 2. So height is 2 sine alpha. And sine alpha in this question is 0.28. Potential energy at y will be mass is 25, g is 10, h is 2 sine alpha. Now, since the surface between y and z is also rough, there will be external force. Since the surface between y and z is rough, there will be external force. There will be external force. Using that energy relationship I did earlier, initial kinetic energy at y plus potential energy at y will be equal to kinetic energy at z plus potential energy at z plus work done against external force. So kinetic energy at y, I've highlighted it earlier. I've worked it out before. That's 400. Potential energy at y, mgh. H is 2 sine alpha. Kinetic energy at z, 0. Potential at 0. Work done against the external force. That the external force is frictional force multiplied by distance covered by the frictional force. So 400 plus 250 times 2. Sine alpha is 0.28 equal to frictional force. Distance cover is 2. 400 plus 500 times 0.28. 140. Frictional force times 2. So frictional force is 540 divided by 2. Frictional force is 270 Newton. But the question asks us to find the coefficient of friction. Frictional force is coefficient of friction times normal reaction. Coefficient of friction is frictional force times normal reaction. Frictional force is 270. What's the normal reaction? Now, the normal reaction, this diagram here. Let me do it. Let me draw it somewhere here. It's like this. The body is sliding down. So when you resolve, here will be weight mg. This space is mg cos alpha. Why this side is, so here is mg sine alpha. These are normal reaction. And when you resolve in inclined plane, at the end of this kind of inclined plane, our normal reaction should be equal to mg cos alpha. Normal reaction is mg cos alpha. Since sine alpha is 0.28, alpha should be arcsine 0.28. So alpha should be 16.26. So 270 over mg is 250 cos 16.26. Put it in your calculator. You're going to have 270 over 240. 0 cancels 0. So 3 in 27 is 9. 3 in 24 is what? 8. That's our coefficient of friction. Thank you. Please subscribe to my YouTube channel. I'll see you next.